Hello, so today we are going to learn about the topic parallel coordinates in computer graphics and visualization. So here we go. These are the points to be covered in this PPT. Introduction. In modern data analysis, we often deal with datasets that have many features or dimensions, far more than can be visualized in standard 2D or 3D graphs. This presents a challenge. How do we see relationships, patterns, or trends in such data? Parallel coordinates is a method developed to solve this. It transforms tables of high-dimensional numerical values into a form that can be visually inspected. This technique enables analysts to grasp the structure of the data at a glance and is invaluable in domains like machine learning, bioinformatics, and finance. This is a traditional 2D scatter plot. Here you can see variable 1, 2, and 3, among which the graph is plotted. And this is a parallel coordinate plot. Here you can see that the graph is plotted among 5 dimensions, that is each axis representing one dimension. So what are parallel coordinates? पैरेलल कोऑर्डिनेट्स प्लॉट मल्टीवेरिएट हाई डायमेंशनल डेटा। तो पैरेलल कोऑर्डिनेट्स जो होते हैं वो मल्टी वेरिएबल्स जो होते हैं ऐसा हाई डायमेंशनल डेटा को प्लॉट करने के लिए काम आते हैं। यूज अ सीरीज ऑफ पैरेलल वर्टिकल लाइंस वन लाइन एक्सिस फॉर ईच वेरिएबल। तो जैसे कि हमने पिछले ग्राफ में देखा तो पैरेलल कोऑर्डिनेट्स क्या करते हैं कि सीरीज ऑफ पैरेलल लाइंस होती हैं, हर एक लाइन जो है एक्सिस जो है वो एक वेरिएबल को रिप्रेजेंट करती है। Each observation is represented by a single polyline. The polyline intersects each axis at the point corresponding to its value for that variable. Example, with 5 features per observation, you draw 5 parallel vertical axes and each observation appears as a line crossing all 5 axes. Particularly effective for revealing relationship among multiple variables, showing correlations, parallel runs versus heavy crossings, identifying groupings or clusters of similar observation. History and origin. So here we can see the history and origin of parallel coordinates. The concept of parallel coordinates was introduced by Alfred Inselberg in the 1980s, originally designed as a method to study geometry in higher dimensions. It was later adopted for data analysis. Inselberg's work laid the groundwork for applying geometric visualization to statistical data, enabling a more intuitive understanding of complex data sets. So why parallel coordinates? Traditional plots struggle as dimensionality grows. Scatter plots effectively handle up to 3 dimensions. Data sets with 10, 20, or 100 features exceed scatter plot capabilities. Parallel coordinates assign each dimension its own vertical axis. Each observation is drawn as a line intersecting all axes at its values. Enables simultaneous analysis of multi-feature trends. Facilitates detection of pattern and relationships across many variables. So now we will see the structure of a parallel coordinates plot. Multiple vertical axes are laid out side by side, horizontally. Each axis corresponds to one feature or variable. Axes are scaled between their minimum and maximum values. A single observation is drawn as a polyline that moves across all axes, intersects each axis at the point matching its values for that feature. When many observation lines are overlaid, clusters and grouping emerges. Overall trends and patterns become visible. Example of parallel coordinate plots. Imagine a customer dataset with the attributes age, annual income, spending score, and credit score. In the parallel coordinate plot, each of these features has its own axis. A customer's data becomes the line that crosses each axis at the respective value. Viewing several such lines allows us to compare customers and identify groups with similar financial behavior or detect unusual patterns. How to read a parallel coordinates plot. So here we will see that how can we read a parallel coordinate plot. First is follow a line from leftmost to rightmost axis to read an observation. Second, each intersection point indicates the value of that feature for that observation. Third, groups of line tracing a similar path imply a correlation or cluster. Fourth, a line that diverges sharply from the rest flags as a potential outlier. Fifth, triangle or slope between two neighboring axes visualize their relationship. Sixth, many lines sloping from high to low or low to high suggest a negative or positive correlation. Now we will learn about the axis scaling. Features can have different scale. Example, income in thousands versus score like a 1 to 100. Plotting raw values lets large scale variables usually dominate. To avoid this, each variable is normalized. Example, via min-max scaling. Normalization makes every axis span the same range. Equal scaling ensures all features carry the same visual weight for fair comparison. Brushing and interaction. So what's brushing and interaction? Brushing lets you select a range of data on one axis. The selected or brushed data is highlighted across all the other axes. This helps you focus on analyze specific subgroups. Acts as an interactive filter, updating the display to only the chosen data. Example, brush high income customers to see their credit scores or spending patterns. Turns a static plot into a dynamic exploratory tool for deeper insights. Axis reordering. The order of axes affects the plot's readability. Placing strongly correlated variables next to each other makes relationship clearer. Many visualization tools support dragging and dropping axes to reorder them. Flexible axis ordering enables initiative exploration of data relationships. Handling categorical data. Parallel coordinates are primarily designed for numerical data but adaptable to categorical data. Categorical values can be encoded numerically, example 0, 1, 2, or placed on a separate axis. Color coding categories helps distinguish groups of lines. Jittering, adding small random offsets, reduces overplotting or identical values. Example, encode gender as 0 and 1, then apply distinct colors to each category. Clustering and grouping. Lines following similar paths across all axes indicate a group of cluster. Clusters can be highlighted by coloring lines according to a cluster membership. Color coding clusters add individual segmentation and grouping of the data. Common use case including market segmentation and customer profiling. Lines that dramatically deviate from common patterns represent outliers. Outliers may indicate data errors, exceptional cases, or novel discovery. In customer datasets, outliers could point to potential fraud. In sensor data, outliers may signal equipment malfunction or failure. Parallel coordinates plot make these deviations usually prominent. Use cases. So here we can see the use cases of parallel coordinates. The first use case is in parallel coordinates is data science. Used in exploratory data analysis (EDA) to examine relationships among features, help identify redundant or high correlated features, aid in understanding the distribution and range of each variable, assist in detecting data quality issues such as outliers or missing values pattern, useful for comparing different models or feature sets by visualizing their output side by side. So now second use case is finance. Financial data encompasses numerous metrics. Example ROI, volatility, market cap, risk factor. Parallel coordinates plot each metric on its own vertical axis. Analysts can visualize and compare multiple portfolios or investment products at once. Enable simultaneous assessment of various performance indicators. Supports informed decision making by highlighting trade-offs across metrics. Facilitates risk assessment through the comparison of volatility and risk factors. Aids in strategy development by revealing the strength and weakness of different investments. Third is health and biology. Medical dataset include numerous indicators. Example blood pressure, rate, glucose level, cholesterol. Parallel coordinates assign each indicator its own vertical axis, enables healthcare professionals to observe how multiple indicators vary together. Assist in diagnostic initiates by revealing covariation patterns among clinical measures. Supports medical research by highlighting interaction between various health matrices. In genomics, thousands of gene expression levels can be plotted simultaneously. Facilitates disease prediction through simultaneous visualization of high-dimensional genomic data. Fourth is cybersecurity. Cybersecurity involves tracking multiple parameters. Example, login, frequency, session duration, IP address, port access. Parallel coordinates assign each parameter to a separate vertical axis. Help visual users behavior patterns across all monitored variables. Unusual activity stands out as lines that deviate from typical path. Example, access to unusual ports during off hours appears as a noticeable deviation. Supports early detection of potential security threats or breaches. Here are some disadvantages and advantages and limitations of parallel coordinates. So here are the advantages: high dimensionality, capable of representing more than 3 dimensions intuitively. तो एक से ज़्यादा डायमेंशंस को रिप्रेजेंट करने के कैपेबल होता है, जैसा कि हमने फिगर में भी देखा था. पैटर्न रिकॉग्निशन रिवील्स ट्रेंड्स, ग्रुपिंग एंड कोरिलेशंस. पैटर्न्स रिकॉग्नाइज करता है, ट्रेंड्स ढूंढने में मदद करता है. एनालॉमी डिटेक्शन, यूजुअल आउटलायर्स आर इजी टू स्पॉट. Inductive capabilities enhances understanding through exploration. Compact representation, multiple features viewed in a single chart. Limitations, overplotting, too many lines can cause clutter and reduce readability. Interruption difficulty, for non-technical audience it can be hard to read. Dependence or scaling. Poor normalization can distort patterns. Order-sensitive insight depends heavily on access orders. Categorical complexity. Handle non-numeric data requires pre-processing. So here is the summary to our topic, parallel coordinates. Parallel coordinates are a powerful tool for visualizing multivariate data. By using parallel vertical axes and connecting lines, they allow users to easily spot trends, correlation and outliers across multiple variables. Despite some limitations with clutter in large datasets, their ability to handle complex information makes them especially useful in data analysis, computer graphics and visualization tasks. With proper design and interruption, they provide deep insights and support better decision making. Here are some best practices. Normalize data. Avoid misleading visuals due to scale differences. Limit dimensions. Too many axes can clutter the view, group or filter features. Use colors and filters. Differentiate categories and groups. Interact dynamically. Enable axis reordering, brushing and zooming. Label carefully. Provide legends and tool tips for better understanding. Here are some references to study more about parallel coordinates. Here is a small demonstration video from YouTube that you can watch to see more, see and learn more about parallel coordinates. So here our topic parallel coordinates is finished and I hope you have understood it. Thank you.